record. Throw a tag up there. So let's start with any questions you have. Do we have to have our appointments file under temp calendars? No, you don't. You can put it wherever you like. You're going to demo the code. So as long as you have access to a file, and if you're working in a group, as long as everybody has access to that, you can put it wherever you like. The temp calendars is just an option if people want to have a shared space. Cool. Other questions? I was curious. I found a switch S and I'm using it in my code in a way that checks to see if a file is empty or not. Can you talk about what S is? Are you using that like in an if statement? So let's so there's a series of conditionals that you can use in Bash to find out information about files. So for example, -E will tell you if a file exists. -F tells you if it exists and it's a regular file. So S is looking to see if a file exists and has a size bigger than 0, so it's not empty. And you can use these in, wherever you would have a wherever you would have a conditional statement. So I don't have a file in here called haha, but if I make such a file and then I run this if statement again, it says, hey, I found that file. So these can be useful for seeing if something exists basically, or finding out characteristics about it. Is it executable? Is it writable? And so on and so forth. And all of this information is in the manual page for Bash. So you got to get through 2,500 lines to get to this, but I just kind of searched by saying dash and pick a switch that exists or that's likely to exist. And I'm just using the N key to repeat that search, and then it brings me down eventually to this section of switches. And as you have time, you can go through the manual page for Bash, and there's a lot of information in there that that can be very useful. So if you search for built-in so I mean, this is all the stuff that we've been doing, loops and things like that. Well, I will find you this thing that I'm looking for another time. But there's a series of options you can set, like no clobber, that will affect how the shell behaves. So for example, if you set up no clobber and you try to redirect file output to a file that already exists, it will stop it from overwriting the file. If you set no EOF, it won't log you out. If you hit Control D, you'll have to type exit to actually log out. So there's a lot of gems hidden inside, not hidden, but tucked away inside Bash. All right, other questions? I just keep going through my manual page while you think about questions.
Yeah, this is kind of like goes into what you were just talking about with no clobber. For the
Hmm.
instances where like people are trying to figure out how to delete an appointment and they, get a version that just wipes the entire file before they figure out, exactly what they're wanting to do. If they were to
Hmm.
use no clobber, it would just stop it from wiping the entire file. Is that right?
Well, no clobber, I think, is specific to if you're going to redirect output into a file, it makes sure the file doesn't exist to begin with.
Okay.
Normally, if I redirect output to a file, it zeroes out the file and starts writing to it. And so no clobber just kind of puts a little safety in there. But for deleting appointments, the way I suggest doing that is, copy your appointment file to a backup, process the backup, and save output to your appointment file. So for example, make a copy of your appointment file and then in a for loop, go through that file line by line, and on each line, if you're deleting appointment, for example, see if the user wants to delete it. If they don't, just go ahead and append that, output that to the bottom of this appointment file you're building. And then at the end, your appointment file is updated. Your alternative is, zero out a new file, process your appointment file, and each line that you want to preserve or each line that you create, append that to your new file. And then at the end of all of that, move your new file to your appointment file. So we don't actually change anything in the original file until the very end here. So if the person starts going through your command and they hit Control-C or something like that, you haven't corrupted your list of appointments. But whatever way you use it, at some point you're going to overwrite the appointment file itself with presumably new information. And it's always safe before you do this, copy your appointment file to a backup, and then move the new file that you built up here into your appointment file. And if something went wrong, you've got a backup of your appointments. Let's see,
So,
chat. Oh, go ahead.
so process makes it so that they can't interrupt it.
No, this is pseudocode. I'm just saying do whatever processing you're going to do on
Oh,
your original appointment file and build a new file
okay.
based on what you're doing.
That makes
Yeah.
sense.
Okay. Let's see. Can we talk about redirecting input in my PA5 project for all the dialog boxes? I must put greater at 2 for them to work. Does this redirect to standard error? Yeah, so it looks like you don't actually need that greater at 2, at least in a lot of cases. So I've been playing with this a little more. So if I say, something like date equals back quote dialogue calendar, you do need this output FD1. But if I do this, put in my dialogue, the type of dialogue, title, height and width, and then whatever other switches I want, and then this output FD1, put that in back quotes and set a variable equal to the result, right? I can go ahead and pick a date, and that will save the date in that variable. The greater at sign 2 is saying, hey, I want to redirect standard error somewhere else. What this is doing, and like I say, this is not entirely convincing to me, but the documentation I found, this is basically saying, hey, the output that the dialogue is normally generating, in this case, the date, send that to standard out. And when you do that, I believe the output that's actually creating the visual dialogue is being sent to standard error. But that's not exactly what it looks like when I dig into that. But the critical part is this is saying, hey, if I capture standard out by doing my back quotes that will capture whatever the dialogue is generating, which for this is the date. For an input box is the input you type, and so on. Let's see, to format today's date, can we do date plus YMD? Yes, that's exactly the way to do it. So if you say date plus %Y %M %D, I am in a random window. Right, so that gives me the 4-digit year, the month, and the day for a date. And if I put that inside back quotes like this, now I've got a variable inside my script that has today's date in it. And so I can compare other dates to that and see if they're in the future or not. How do you find the number of lines in an appointment file? WC is useful for finding information about a file. So this tells me 391 lines, this many words, this many characters, and that's the name. If I type this and I pipe it into awk and I say print $1, that gives me just the first field, which is the number of lines. And if I put that all inside back quotes and store it in a variable, now I have a variable that tells me how many lines I had in my file. I think you can also just do WC-L and that says, tell me the number of lines, but this also works.
Can I ask a question?
Mm-hmm.
How to save the output to the appointment file? For example, if the user pick December 12th is the appointment day, how do we save December 12th into the appointment file?
All right, so let me make my bogus appointment calendar list. I don't know, I don't play tennis. So there's my appointment file. So you run a calendar dialogue and you let the person pick a date and you get a date, that looks something like this. And then you can use awk to break that up into a year, month, and a day. And ultimately, you end up with a date that looks something like this, 2022-1125. And then you say, enter a description of your appointment, and they use an input box or something, and you end up with a description like, eat food. All right, so I want to record a new appointment on this date with this description. So it can be as simple as something like this. Right, this will echo the date, followed by a pipe, followed by a description. And then this greater says append it to this file. So if I do that, and then I look at my appointment file, it's got this new appointment on the bottom.
So APPTS is your appointment file name, right?
Right.
Okay, got you. Thank you.
Okay. Okay, so if you put dialogue commands in a function and you're trying to return a string, yeah, you may need that greater than at too. But maybe not. My best understanding is that that's going to manage the case where you get an error message from the dialogue. But if it works without it, leave it out. If it works with it, you can go ahead and leave it in. Can you please talk more about how to do the upcoming assignments part? You mean showing a list of upcoming appointments? All right, so let's suppose we want to know all the appointments that will be happening from today on. So date equals back quote date plus %y. Let's make a little script. So let's show future appointments. Today is going to be, taken from today's date. And so this has the format YY, YY, MMDD, which is also the format I'm using in my appointments file. All right, so I'm going to make a while loop here, which is going to read from the appointments file one line at a time. Each line that it reads is going to be stored in a variable called next appointment. So when I run this, each line is going to look like this. So let me develop this on the command line, right? So as I go through my loop, next appointment's going to look like that. So a date and a description. So let me pretend that I've got a variable that I've read in through that loop. And I want to figure out what the date of this appointment is, which is just this first 8 characters. So I could do something like awk. Let's do a field separator of a pipe, which I've escaped because pipes are symbols. And if I do that, and I say print the first field, and it gets a line like that, it'll just give me that first part, just the date. So I'm going to say something like appointment date equals right? And this will run awk field separator as a pipe, and this will just print out the first field, which will be year, month, day. But I don't want to read standard in. What I want to do is look at this variable next appointment that I read from my file and print out the first field. So I'm going to do the following. I'm going to echo that line that I read from the file. I'm going to pipe that into standard in of awk. Awk is going to say, okay, let's break that input line up into fields separated by a pipe, and let's print out the first field. And then all of that should generate, an output that's just the date of that appointment. And since this is in back quotes, the value of all of this will be that date, and the appointment date will get set equal to that appointment. And if I want, I could do the same thing here and say appointment description and print out field 2. Let's do some debug prints. All right, so we're reading our file one line at a time, and we're breaking it up into a date and a description. And right now we're just going to print those out just to see if we're doing this correctly. And so looks like, you know, on the 15th, it found this appointment, 16th was this appointment, and so on and so forth. So far, so good. Let's get rid of our debug statements. To see if the appointment is scheduled for today or the future. So if appointment date is greater than or equal to today, then we'll go ahead and show the appointment. And I'll just print a message, do the appointment description on appointment date. So here's my appointment file. And if I run the future command, oh, that was anticlimactic. If I run the future command, it says, hey, do this on the 17th, do this on the 19th, do this on the 25th. And, you know, it doesn't depend on my appointment file being sorted in any particular way. I can have appointments all over the place. And because I'm just going through it one line at a time, whenever those are encountered, it prints those out. So the theme here is, right, we're writing a program, right? It's possible sometimes to find a big, long, you know, combination of sed and awk and grep, and you pipe this into that, and you add some switches, and you may be able to come up with a one-line statement that will do something like show you future appointments or delete an appointment or something like that. But we don't have to do that, and we shouldn't be looking for ways to do that, right? We're working in Bash. Bash is a programming language. So think of more of kind of a mindset for what you have with C programming assignments. Think of algorithms. Well, first of all, think about what you want to do, right? If I want to delete an appointment, how would I like to do that? Do I want to see a list of 500 appointments and I go through and pick the one I want to delete? Do I want to specify a date and see all the appointments on that date? Do I want to put in a keyword and look for appointments that have that keyword, right? Envision from the user perspective, what would you ideally like this program to do, right? And pretty much anything that you can envision, you can code it to do that. And so probably a first step is to get a fairly clear idea, at least an initial idea, what your goal is for the program. And then go ahead and start writing code, right? So, I mean, this is an algorithm like what we would do in C, right? If you're searching for a keyword in a file, you read each line of the file and you look to see if it contains that keyword. Well, kind of the same idea here. It's very unsophisticated. It's very inelegant, but that makes it fairly straightforward to code. But we're taking advantage of the fact that we have things like awk, you know, which will break up a field, a record for us into different fields, or sed that will do substitutions for us and so on. And then, you know, figure out your algorithm and then start writing lines of bash code to do that. And this is, you know, just one way to pull out future appointments. There's a bunch of other ways. There's a bunch of other ways to break your input field into your input line into fields. You can do that with sed. You could do that with some other things. But with the things we know so far, which is like, you know, if statements, while loops, assignment statements, back quotes, $signs for evaluating variables, awk, sed, and dialogue, right? That's probably enough to do most of what we're going to envision doing. And I think it's more fun and a better learning experience, and usually more successful, to take what you know and find ways to put that together, instead of looking for, you know, sort of a pre-built solution, if that makes sense. Thanksgiving is the 24th. Oh, I'll eat leftovers on the 25th, I guess. All right, so does this help? If I wanted to make a file of future appointments, I could do something like this. Right, I'll either create a file called appointments.future, or if that file exists, I'll zero it out. And then down here, I can say greater than appointments.future. And now if I run future, it doesn't display anything, but I have this appointments.future file that has that same information in it. And now, you know, what can I do with that? Well, I could display that for the user in various ways, including, you know, showing them a dialog box with this. All right, good. Other questions? All right, so let's look at ODPs. So 421 was due this morning. Or due yesterday morning. And that was the sum function that would take an array of integers and return the sum. And because this is a C array, we don't have a way of knowing how large the array is, how many integers we have. And so we have to pass that as an argument. And so sum.c can be something like this. So initialize a running sum and make sure if you want something to be 0, you actually set it equal to 0, because that's not guaranteed. And then if we're told we have 5 elements, then the indexes are 0, 1, 2, 3, and 4. So the last index is going to be length minus 1. So here I'm looping while I is less than length, which means the last value for I will be length minus 1, and just add each element to your sum and then return your sum. All right, and then ODP 423, which is due Friday, similar setup, except in this case, we're going to take an array of integers and we want to reverse the elements. And we talked a little bit about this on Tuesday. The main thing to think about here is imagine something with 5 characters. We want to do the following swaps. So we want to swap elements 0 and 4 and elements 1 and 3. And element 2 is in the middle, so we don't really, you know, want to swap 2 with 2 because that's silly. if we had something with only 4 characters, then we would be swapping 0 with 3 and 1 with 2. And so you can start to see a pattern, which is, you know, we're going, if length is equal to 5 or length is equal to 4, we start with element 0 and we swap it with element length minus 1. That's the last element. So one general approach might be to start off with a pair of variables. I recommend something more meaningful than I and J, but you know, a variable that points to the first character and a variable that points to the last character, and we're going to swap these with each other. And then we're going to increment I and decrement J and swap those two. And we can keep doing this until I is no longer less than J. So if I and J are equal to each other, or if I is bigger than J, then we're done. And so if you think about it like that, it's not a bad algorithm to envision. And just remember, if your length is equal to 1, you don't have to do anything. If your length is equal to 0, you don't have to do anything. So you can start off with, you know, if string length is less than or equal to 1, just return. There's nothing to swap. And that kind of throws away all the edge cases. And then otherwise you can do something like this. All right, so someone asked, how do some of the other dialog boxes work? So there's a number of them. So we can do a message box, which displays a message and waits for you to say okay. We can do an info box, which simply displays a message in a box and then just exits. And so we can, you know, pop up some information, but it's not going to pause your script. And so you may need to do a message box instead. We can do an input box. Which displays, you know, whatever message we want and lets the user type a line of input. And so these things that are generating output, whether it's a calendar or an input box or something like that, this is where we're going to do the output FD1, and we're going to put the whole thing inside back quotes, and we're going to say, you know, variable equals all of that. And so now if I type something in there and I echo that value, I'll see whatever the person typed. And there's text boxes. So I can say dialogue, text box, and the name of a file. And I'll get a big window that shows me the contents of that text box. And I can scroll through it with my arrow keys and hit exit when I'm done. And if I just say dialogue, it gives me a usage message. And the box options, these are all the different types of dialogues we can create. So calendar, we've seen. Checklist gets fancier, but we've talked about those. Edit box, forms get super fancy and gives you, you know, a dialogue with a bunch of boxes that you can type over and fill in. Input box and so on and so forth. Yes, no is useful.
Is there one that lets the user choose from a bunch of options, but more than just yes or no?
You mean like filling in something for more than one line?
No, like choose among 3 or more options.
Yeah, so
Menu.
you could do it. You could do a checkbox.
Choose
There's
one
also a
out of 3
menu
or-
and I think a radio list.
Yeah, so radio
Choose
lists are
one.
nice.
Yeah, choose 1 out of 3 or more options.
So
Like,
dialogue
would you
radio
like
list.
to? Like, would you like to edit appointment, add an appointment, view all appointments?
Yeah.
Yeah, pick one of those
Um,
options.
So you can make a radio list. So let's go 3 options. So let's say view appointments, and I'll call that 1, and I'll make that on. Delete appointments, I'll call that 2 and make that off, and edit appointments, I'll call that 3 and make that off. And so now I've got, options. And whichever one I pick, this will output, the matching string. So maybe I should have done these in a different order, but you get the idea. Something like that. And so I can hit a 2 or a 3 to move down to one of these items quickly. I can click, or I can hit a space bar to actually select one. And then when I say okay, this will just output the number that was selected. And so I can put the output FD1 on the end and put the whole thing in back quotes and capture that. So that's a pretty standard way to allow the person to make one choice.
Can I ask a question?
Mm-hmm.
What does 0031 means on the bottom?
So 0, 0 is the height and the width, and every one of these commands wants a height and a width argument. 0 just means size it yourself, figure out a size that looks good. 3 is saying I'm going to give you 3 lines of things to display. So if I only wanted 2 options, I would make that a 2. And then this is the first line. So the shortcut is a 1, that's the name, and the default is for that to be selected. This is the second line, 2 delete appointments, and that's not selected. And this is the third line, 3 edit appointments off.
Thank you.
Mm-hmm. So on means choose that one by default. So if I make this last one on and make this first one off, then it starts off with this one selected.
Can
So
you
it's just
have
picking
more
an
than one
initial.
on? Can you have more than one on at the same time?
With a checklist, you can. I don't know what it will do with a radio list. It will either blow up or just pick one of them. So it looks like it picked the first one. Because by definition, a
happens
radio
if-
list can only have one thing selected.
And what happens if they're all off?
All right, so nothing selected. So I can select one, or I can have none of them selected. So again, mess around with these. Try a checklist, see what that does for you. There's other options. I mean, I could display a list of options and use an input box to say, hey, which option do you want? And they could type in a 1 or a 2 or a 3, and that would work too. So there's different possibilities. Some people are having it say, I'm just going to show you all your appointments when you first start, and then I'm going to ask you if you want to delete any of these. And if you say no, then I'll ask you if you want to edit any of these. And you can put something together like that maybe. So again, think about the use case. What would you prefer to have your interaction be if you were running this as your own personal calendar? And then try different dialogue options And, you know, there's a lot of options we have not played with. And mess around with those, see if there's something that looks like it works well for what you want. And so sometimes a big part of writing a particular program is learning about the language or the tool or something like that. So I remember I took a course on programming languages as an undergrad, and the first week our homework was learn Pascal. And then the second week was a program we were supposed to write in Pascal. Pascal was an old programming language. And it was just like, you know, that's your first homework, is to learn this language. And the more you work with different languages, the more you work with different tools, the easier it becomes to learn those. Once you understand, you know, how to work through a manual page, once you know that if you type a command without any of the required switches, it will usually give you a usage synopsis. And you get enough experience to start trying some of these things, right? Well, then it becomes much quicker to learn how to use a new utility or a new tool. And so this is not, you know, oh, I've got to like figure out this stupid dialogue command so I can finish my assignment, right? This is building skills. The process of learning how to use this particular tool will help you with learning other tools down the road. So it's time consuming, but with a good outcome. All right. Other questions about this? All right. Let's grab that. All right, let's find Canvas. There we go. So I posted a file yesterday, and I've modified it a few times. So if you haven't downloaded this recently, go back and grab the latest copy. So it's just called Useful Bash Commands. And this was an attempt to sort of gather in one place some of the concepts and specific commands we've been using in this course. We have not gone through all of these yet. We've gone through a lot of these, and some of these you may have seen me use, but we haven't necessarily talked about them in detail as to what exactly they do. So I don't want this whole course to be just me standing at a board or in front of a piece of paper and just spewing out, you know, a bunch of commands for you to memorize or something. So we've been picking these up on the way, but we're coming to the end of the course. And so I want to make sure that we've gone through all of these things, at least mention them. And if there's stuff on here that I've never talked about, don't panic over it, right? I'm not going to throw a bunch of questions at you on an exam about commands that we haven't been using throughout the course. But these are things that if you know these exist, they will probably, at least some of them will be useful down the road as you continue to work more and more in Linux, and especially in Bash. So the concepts, most of these we already know, but I'm just kind of summarizing them here. So, you know, assigning a value to a variable, so you can say variable equals such and such. And then you use a $sign to get the value of a variable or an expression to do arithmetic. We know about back quotes. If you put a command in back quotes, the command is executed, the output is captured and is used as part of an expression. We can redirect standard out using a greater than sign. So you run a command and say greater than file, and the output of the command goes into that file. If you just do a greater than, the file is truncated in the beginning. If you do two greater thans, it appends to the end of the file. And if you do less than file, then it redirects standard in. And so instead of reading from the keyboard, it will read from the contents of a file. Let's see, chat question. If we have extra time, could we talk about graphs or Dijkstra's algorithm from 215? Don't want to do that here. We will dig into that in 222. When we talk about trees and such, we'll get into a lot more detail and some code. But we'll do examples of Dijkstra's algorithm Friday in class. And we can talk more about it then for sure. All right, standard in, standard out, standard error. These are the three main streams that commands have when they're executing. This is where it reads input from. This is where a command writes output to, and this is also an output stream, but it's intended for sort of non-standard output. And the idea is if I run a command and I try to capture the output, I probably don't want to capture error messages. I may want to run a command that, does something, produces some useful output. But if something unusual happens and the program needs to get my attention, if it just does a printf, that message saying, hey, here's an important message, is just going to go into the output file along with the other output. So I can print to standard error. And if I'm redirecting with a greater than sign, that message will still appear on my display instead of being sent into a file. We talked about associative arrays, also called hashes, and we looked at declaring them, declare dash uppercase A, using them, storing things associated with an index, retrieving things associated with an index, and iterating through the space of all available keys. Regular expressions we've been playing with for a couple of classes now. Special bash variables $ question shows us the status of the previous command, which we can use, for example, the yes no box to know whether the person clicked yes or no. $number is the number of arguments in a script, and then the arguments themselves are available in $1, $2, $3. Greater than versus double greater than is something like this. So I've got three commands I've executed. Each one said greater than sign haha. If I look at haha, it's only got the result of that last command I ran. So a greater than sign zeroes out the file and then executes this command and sends the output into that file. But if I say date greater than haha and then print working directory greater haha and then echo hello greater haha, those double greater than signs mean append. So it does the same thing as this, but if the file already exists, it does not zero it out. It just adds to the end of the file. And so that can be useful in PA5 for building a file to either display or replace your appointment file and so on. So double greater is append, single greater is just overwrite. Welcome. Control C is our usual way to interrupt a process. And that says, stop the process and let the process die. Control D is how we signal end a file if we're reading from standard in. And standard in is our keyboard, and we want to signify that there's no more input available. We can hit a Control D. And the C functions like fgets and getCar and so on will interpret that as saying that the input has hit the end of the file. And we can capture that information and respond to it accordingly. We're going to talk about jobs and processes later, so I'm going to hold off on Control Z, background, foreground, jobs, all of this stuff. We'll come back to this at the end of class today or on Tuesday. So we'll skip over those for now. You are allowed to use for loops where you iterate over words in a list. So for variable in list, where list is, say, you know, a set of things with spaces in between, this will be a loop, and each time through the loop, variable will take on the value of the next word in this list. And we did this mainly when we were looking at iterators for associative arrays. We can use some bizarre syntax to get a list of valid indices separated by spaces, and then we can iterate over those with this for variable name in structure. Another kind of loop we talked about is while read variable do, and at the end, instead of just saying done, we say done less than in the name of a file. So this was this code we were playing with a little while ago today, where we're reading an appointment file one line at a time. So while read variable do is that syntax. The other thing we've talked about that probably won't come up in this assignment, but we can say command less than and some sort of label or mark, and then put in a set of lines and then have a line just with that label on it. And this will execute this command and take all the stuff in between and feed that to standard in. So we can run a command inside a script and specify input for that command by using that. We talked about paths, either paths for directories or paths for files, and absolute versus relative. Absolute usually begins with a slash. Relative is based on where you are right now. Tilde means your home directory. And so that's sort of absolute wherever you are. Tilde means your home directory. Tilde followed by a username means that user's home directory. So if you say tilde Nick, that's a shortcut for /home/Nick. And then dot and dot always represent your current directory or the parent of your current directory. So dot lets you move up. Dev null is a file that you can write into, and whatever you write disappears, and you can read from, and it always returns end of file. So it's a black hole. You can write to it and your output disappears. So if you're running a program and it's generating output that you don't care about, you can run the program and say greater than dev null, and any output just goes away. So it keeps your screen clear. File hierarchy is just the idea that there's this whole directory structure starting with /, which is the root directory. And there's a tree-like structure, basically. Each directory, except for / has a parent directory and may have subdirectories. And our path names, right, if we make an absolute path or a complex relative path, it's usually a list of directories separated by slashes. And it just follows the usual structure. History is a nice way to recall previous commands. So if I say history, that'll show me, in this case, my last 2,000 commands that I've executed. So you can go back and see what you've done. If I want to recall a particular command, like my dialog box there, I could say !1999, and that'll repeat my dialog command. Or I could repeat my last command that started with a particular something. So if I want to repeat my change mode command, I could say !change mod or CHMO, and it'll go back through my history and find the last command that started with this and execute that. That's a kind of dangerous command structure to use sometimes. And if you do 2 !, that just gets you your previous command again. You can also, just up arrow. Aliases, let us make a new command basically that represents an old one. And so the structure for that is, you know, alias new equals old. And now whenever I say new, it will execute whatever old is. So I could say alias box equals this stuff. And now if I just say box, bingo, it pops up my dialog box. Path is a variable that we're well equipped to understand now. If I echo $path, it's just another variable. But this particular variable is used by Bash to figure out where it should look for programs. So if I say ls, it's going to look in my current directory for a program called ls, because the first thing in my path is dot, which means my current directory. If it doesn't find an ls in there, it'll search this directory. If it doesn't find an ls there, it'll search this directory, and it'll keep going until it finds an executable program named ls. And if it finds it, it'll execute it and then exit. If it doesn't find it, it'll say, man, not found. So path is just a particular shell variable that's used to find executable programs. PS1 is a prompt. If I set PS1 equals haha, then my prompt is haha. And there's a bunch of shell variables that you can set that you can use that have different meanings. If I look at random, sorry. Yeah, if I echo random, I'm going to change my prompt back. So if I echo $random, that gives me a random number. And it looks like a random 15-bit number. So sometimes you need a random number in a script, pretty easy to generate. All right, bash RC is this source file that contains bash commands we want to have executed when we first log in to our shell. And so all of these commands basically get run each time I start a shell. And, you know, it controls history. I want to record, you know, 2000 commands in my history file. And I want to set my prompt PS1 to be certain things. And some of what I do in here sets my path to be something or another. And so on. I make some aliases and stuff like that. So you can put whatever you want in your bash RC file, and it gets executed each time that you begin a bash shell. And if I just say .bash RC, I get a weird error, right? But remember, when you run a bash shell, a new shell is created to execute the commands in that script. And so even though my bash RC sets my prompt, it doesn't actually change my prompt here. So there's another command called source. And source basically says, open up that file and execute each of those commands in my current shell. So when I do this, the command that sets my prompt will actually change my prompt. And so in PA5, if you're writing a file of functions, so, you know, here's my fun file, and I say function blah, right? If I execute this file inside my script, that does not define the function blah for me, because this function is being created in a separate shell. And when that shell exits, this function goes away. So instead of executing this inside my script, I could say something like source fun file. And now it pretends that all of this is inside my program that I'm executing, and that creates the function blah. So you can start to partition pieces of your script into other files and functions in particular, I can define those in a separate file and keep my main script a little cleaner. Yeah, perfect. All right, and then write was this command that we played with the other day, where you can write to another user if you have permission turned on to receive messages. So if I say message yes, and I say write to Nick, I can say hi Nick, and let me do this on the server. So let me write to Nick. So I say write Nick, I'm logged in as N Macias over here, and Nick gets a message saying, hey, you got a message coming. And I can say what's up, and send messages that way. And if I don't want to be disturbed, I can say message no. And then if somebody tries to write to me, it'll say messages are disabled. Or by default, messages are enabled. So that's a command that might be useful if you want to do something like have your calendar program send you a message. You could use write for that, for example. I get the weirdest spam on this additional comments. Contemporarily is the hurry to at senior Shufti at in. There won't be another odds like this. Hey, buy and transport cryptocurrency in minutes. All right. All right, let's take a 5-minute break, and then we'll come back and we'll go through these commands. And like I say, a lot of these we've already seen, we already know, we don't have to say anything about them, but some of them are new. Some of them we may have seen, but not really talked about in detail. So let's come back in 5 minutes. And we'll say 11:10, so 5.5 minutes. All right, so I'll see you back in a few. Hey, I'll be back in about a minute. All right. Juggling 3D prints in the background. So let's go through some of these commands. So you know about echo, right? Single quotes, double quotes have different meanings. The main switch we play with echo is -n to say don't print a new line at the end. So we can do multiple echoes and build a big long line. Read is the other direction. That's for taking in input from standard in. -p does a prompt, -s turns off the echo, and -n followed by a number says come back after that many characters. So if you want to respond to a single keystroke, you can do a read -n1. ls for listing files, and probably the most common switch we use on that is -l to see a long listing. And all of these commands have different switches, and if you look at the manual page, you'll see lots of different options. But the majority of these, you know, we can just run the command directly, or maybe there's a few switches that we find particularly useful. So this isn't the only option on ls, but it's definitely an important one to know. Date shows us the date. Say, most important command in the entire system. Copy, move, and remove are for manipulating files. And most files, most commands on Unix have this general form of like old, new, or source and destination. But if you're not sure what the order is, check the manual page or try it with some test files, right? So copy, for example, copy old file to new file. Move, which is rename. Move old name to new name. RM is just remove, so it just deletes a file. Make dir creates a subdirectory, and it can be a relative subdir. So if I say make dir X, that's going to create a directory under my current directory, because that's a relative path name. If I were to say make dir /X, that would create a directory under the root directory /X, which I probably can't do. But if I said, you know, /home /Nick /CSE224 /X, that's the directory that would be created. So this relative absolute path business is topical. And then rmdir removes a directory, but with the complication that it will not remove a directory unless the directory is empty. So I can go into the directory and I could say something like, you know, rm star, and then I could move up one level and remove the directory with rmdir. But that's a bit of a pain. And if my directory contains other directories, I can't remove those with rm. I'd have to remove each of those, and I'd have to move into those directories and remove the files and so on. So a cleaner way to do this, but very dangerous, is rm-rf. And if I do rm-rf star, that removes everything from my current directory on down. And it will do this without warning. it won't say, do you really want to do this or anything like that? It'll just boom, delete. So if I did this in my home directory, every file on my directory is gone. Every file I've created, every Git repository, all of that, poof, done. So pretty powerful command, right? But if you're certain that you want to delete a directory and all of its subdirectories and files, that's a way to do it. All right, so CD lets us move around directories. So there's always a notion of what your current directory is, which means if I just say ls, what directory is it showing me the files for? Well, whatever my current directory is. So CD by itself with no arguments moves me into my home directory, the same directory I'm in when I first log in. CD followed by a path moves me to that directory, and this can be relative or absolute. CD tilde will also move me to my home directory. And then PWD, print working directory, tells me what my home directory, what my current directory is. So if I'm sitting right here and I say PWD, it tells me, hey, you're in home Nick. I'm in my 215 directory, but if I say pop directory, it'll take me back to my 224 area. And I can go into fall 2022, but maybe I want to push into my older area and go into fall 2021. And I can do some work in here. And if I want to come back to where I was before, right, I can just say pop directory. And now I'm back to fall 2022. And you can push and pop multiple things. Right, so now I've got 4 directories that are being remembered. There's the directory I'm in right now, which is the homework directory. There's the previous directory, which is the root for fall. There's the 224, there's files, and I started off in tilde. So yeah, it's your breadcrumb trail, exactly. And so if you've done engineering 270, we talk about stacks. This is a stack, right? And push D is pushing my new directory onto the stack, and pop D is removing from the stack. So we'll talk about stacks in 222 in winter. All right, so which is a useful command to know if I type something like VI, what program is going to be run? So if I say which VI, it'll say, hey, you're running VI from user bin VI. If I say which ls, hey, you're running ls from /bin/ls. So it searches that path variable to see exactly what it is that you're going to run. If I say where is, this will search the file system and show me things related to VI. For example, user bin VI, that's the executable program. This is where the manual page is kept. This is where another part of the manual page is kept. And if a command exists in more than one area on your path, where is will show you the different locations where it exists. So that can be useful. File is a good command. If you want to know something about a file, file will tell you that. So so if I say file final, it'll say final is a directory. If I say file this thing, it'll say that's a Microsoft Word document. If I say file useful commands.pdf, it'll tell me that's a version 1.5 PDF document. If I say file, the name of this, it tells me it's a JPEG and it's 96 by 96 and all this stuff. So it's a general command that will give you some information about what's going on in a file, what kind of file it is, some basic information, and so on. All right. Cat is a command which you can use to look at the contents of a file. So if I say cat data, that shows me the contents of this file. And it just scrolls out on your screen and it flies off the top, you know, as quickly as it possibly can. So if I want to look at the contents of a file in a more controlled way, I can say more, name of the file, and it shows it to me one screen at a time. And I can move through with a space bar or an enter key and so on. And you can also say less, and that's a different version of more. That's some people prefer. All right, df is a command for looking at information about the devices on your system. We've looked at this before. So there's a name of a device, there's its size, that's how much is in use, how much is available, percentage of use, and where it's mounted in your file system. So if I go to /, I'm pointing to this device. If I go to /dev, I'm pointing to a different file system. So that can be useful. Watch is a command that we can use to run another command repeatedly. So for example, I can say if config, and I can see what my network is doing. So this is my Ethernet cable, which is how I'm connected to the net at home. This is a loopback adapter for testing purposes. This is a wireless adapter. And if I do if config again, so here's my local network address. Here's how many bytes I have sent and received. And if I do if config again, I'll see the same information displayed, but some of it changes. So if you want to monitor your network and see, you know, what kind of traffic you've got, I can keep typing if config, and I can see these numbers go up, and I can tell I'm using my Ethernet, I'm not using Wi-Fi. And there's, you know, some bytes being sent back and forth. That's because I'm doing Zoom. So watch is a command that you can type something else after, and it will execute the command automatically for you by default every 2 seconds. So this will just keep updating every 2 seconds. And so it's a nice way to sort of watch what's happening on your system. Or if you have a command that's generating output and you want to, you know, look at part of that output, you can use watch and so on. And it's got, you know, a manual page and a few options. So I can set the interval. So if I want to watch every 1/10 of a second, this should update, you know, 10 times a second. And, you know, if I say if config, I get all of this information. But if I just want to see how many bytes I'm sending and receiving, I could pipe that into grep and search for the word byte. And now I just see, you know, receive and transmit packets and bytes. And so if I put watch -n in front of that, now I've got, you know, a display showing me my network traffic. And if I only care about those first 2 lines, I can take this and pipe this into another command we'll talk about called head, which says just show me the first 2 lines at the head of the file. So we can put commands together a lot of different ways. So watch is a nice one if you're trying to monitor something. If you're trying to set up a network and you're looking at signal strength or something, you can monitor it with a watch while you walk around the room, stuff like that. All right, VI, everybody knows about VI, right? So nothing more to say on that. GCC for compiling a program, and we've got some switches. O to specify an output file, C for object file creation, -G for setting up debugging, GDB for running the debugger. grep is for searching a file or, you know, some stream of standard in. So over here, I did a grep for byte, which runs this command and searches the output it generates for the word byte, which gets me, these lines here. -I ignores case, -V reverses the search and shows me lines that don't contain this pattern. Awk is a command. We'll probably talk about it a little more next week, or maybe the last week, depending on how much time we have left. Awk is an entire programming environment, but you can get pretty far if you know exactly one thing you can do with awk, which is awk. Single quote curly bracket print $1, for example. And this is the most basic use of awk. This will just read from standard in, and the $1 says print out the first word that you find. So if I print $2, it prints the second word. If I print $2, $1, it prints the second word followed by the first word. And that by itself, just that functionality of awk is really, really useful. And PA5 in particular, it's useful for taking, responses from dialogue, for example, and breaking them up into fields, or taking appointments from your appointment file and breaking them up into fields. And the one switch you should definitely know is -F followed by a character says, hey, instead of separating my input with spaces, I want to separate it with commas. So if I say 1, 2, 3, 4, 5, this will print out the second field 2 followed by the first field 1. Or if I put a comma in here, right, it'll print the second field followed by a comma followed by the first field.
So that 2-1 is a string and not the number 21.
Correct. So if I say echo that and pipe it into awk, I get back a 21. If I put all of that in back quotes and save it into a variable, that's my variable. Now, is that a number or a string? Well, it's always a string, right? Because that's the only thing Bash really knows about. But I could, I can do arithmetic on it by using our double parentheses trick and treat it like an integer. Or I can compare it to other integers by doing -EQ or -GT and so on. But yeah, it's really just a string. All right, so that's the version of awk that will get you most of what you need. The one version of sed that you need is basically substitute old /new. Possibly with an extra G added on the end here. Just this one form of sed is dynamite, right? Because I can say substitute a comma with a space everywhere on a line. And now if I have a line separated by commas, it changes it into a line separated by spaces. So we can use awk and sed to do these kinds of simple manipulations, and we can combine them with other things by, for example, taking a string or a variable, echoing it, piping it into awk or sed, and then doing some business with that. So there's my date. I can pipe that into awk with a field separator of /. And if I print field 3, that gives me my year from the date. All right, TR is one we have not talked about. TR is just a translate function. So for example, I can say translate space to an underscore. And if I type in a string that has spaces, those spaces get changed to underscores. Now we can do that with set also. I could do substitute slash space slash underscore, but TR will also work with ranges of characters. So for example, I can say, take the lowercase letters A through Z and replace it with the uppercase letters A through Z. And now I've got a single command that converts things to uppercase.
Man, we should
So that
learn
can be
about
useful.
that in the PA2 or whatever.
Yeah, yeah. All right, head and tail just give you the beginning or the ending of a file. So if I say head-5 data, let me go back to the server. Head-5 data gives me the first 5 lines of that file. Tail-5 data gives me the last 5 lines. And this can also be useful when you're executing a command and you want to see the end of the command. So, you know, like df shows me a bunch of stuff that I don't really care about. I just want to see the beginning of it. So I could say df pipe into head 5, and now I can see, you know, the partition I care about, which is this one, and see how full it is and so on and so forth. So you can use head and tail on files or on anything that generates standard in, just like all of these commands. So sort, just alphabetizes. So that was my input above, here's my output. So it just sorts it. And by default, it makes certain choices. For example, even though the ASCII code for C comes before the ASCII code for little a, it's sorting this alphabetically. But if I sort a bunch of numbers, the 10 comes out before the 5 and the 6. Why? Because as strings, this begins with ASCII character 33. And this begins with ASCII character 36 or 37. And so a 1 comes before a 5, right? This is sorting these things alphabetically. If I want to sort as numbers, right, I can do a -n switch, and now it sorts these things numerically. But there's, you know, a zillion options on sort. I can choose which columns I want to sort by and so on and so forth. So all of this stuff, if you want to do something more nuanced, right, ignore leading spaces, put things in dictionary order, numeric order, pick particular fields or words to sort on and so forth. All right, SSH is for connecting to a remote machine or remote service. And you've been presumably using that from the beginning. SFTP is for transferring files. So it connects and logs into a remote machine, but then it lets you use commands like put and get. What's a good way to get a single line from a file? Well, which line would you like? So I've got, you know, War and Peace, but if I want line 4, so an easy way to do that would be to say, let's take the first 4 lines of the file and let's pipe that into tail-1. So now I've got the 4th line. There are a lot of other ways to do that, but that works. Yeah, exactly. All right, SFTP connects to a machine and lets us transfer files back and forth. Ping is a nice one for checking to see if your network's working. So I can ping google.com and it sends a message to google.com, whatever machine is associated with that name, which is this IP address. And there's a server sitting on that machine that responds to the ping. And so it sent, 64 bytes back, and it took, around 13 milliseconds to do that ping. If I ping localhost, that's a really fast operation, right? That's using a built-in loopback. So, it's a fraction of a millisecond. If I ping Clark, that takes, 50, 60 milliseconds to reach Clark's server and get a response back. And so you can use ping as kind of just a quick pulse check. If things aren't working, you can start pinging, usually Google's always up. So you can ping Google, and if the request times out, your network's probably down. So that can be useful. Change mode we know about, that sets the permission bits on a file. And remember, those permission bits are permanent. So if I write a script and I want to execute it and I just type the name, it'll say permission denied. I type this command once, it changes the permission bits to make it executable. I don't have to type that again. Only have to type it once, right? Unless I want to change the permission bits again. WC word count gives us lines, words, and characters. So War and Peace, 63,000 lines, 562,000 words, and I think 3 million characters. All right, unique is a nice way to deal with files that have the same line more than once. So here's a problem with recording. I would normally do this by saying who and showing the who command, but I don't want to record students' usernames and post that on YouTube. So this is why I'm not going to record after this quarter. But I don't think I have anyone. Yeah, I'm logged in 3 times here. So I could do who on my machine, and I could pipe that into awk and print the first field and see my username. And if I only wanted to see that once, right, I can pipe that into unique and just see, one entry for Nick. And then if somebody else was logged in, I'd see their entry and so on. And who, is a way to see who's logged in. Dmessage is a good command. This is a bit of a system level thing, but system level messages get recorded in a file that you can look at with dmessage. So my CPU is always overheating. I'm not sure why, but I get these messages about, package temperature above threshold and so on. And that seems to be what most of my messages are, but I could say dmessage and I could pipe it into grep-v temperature, and it will show me messages that don't have the word temperature. So now I can see more interesting things, error messages from my camera viewer and so on and so forth. All right, so strings is a useful way to look at a file that might not be readable normally. So let me see if I have a file. I'll go back to the server. So I have this file called curses, which is an executable program. We did this for a demo of using n curses to do some drawing. If I vi curses, it's not really legible. It's got, a little bit of human readable stuff, but a lot of stuff that's just gibberish. If I say strings curses, strings will go through and look for strings of human readable characters and just show me those. So I can see, some information in here that's possibly useful to me. And it suppresses all the stuff that's just going to look like, non-printable characters. eSpeak. Is not on the server. Hello, Will. right? So I don't know if you can hear that, but that's just a text to voice.
Hello world.
Yeah. So but it's, you know, it's just a Linux command, so I can say date and pipe that into eSpeak.
17 log 2022 11:41 29 a.m. PST.
Right, so that gave me a spoken version of this, and it's got a billion switches. So I can change the pitch and the speed and the voice and all kinds of other stuff. And some of these work well, some of them don't. So I can do -S and change the speed to, I don't know, 40.
17 log 2022 11:42 01 a.m. PST.
Right, so it's not something we're going to use on a regular basis, but it's something that's useful sometimes. Yeah, I think you can change the voices, and there's a lot of options, and some of them work better than others as far as actually existing or just doing the default voice, but you can pick and choose. So if you've got something running on your system that's, you know, monitoring a process or going to let you know when some program is finished or something like that, you can have it use voice instead of, you know, popping up a display on your window. You can get your attention that way. So I think I mentioned in the other class in 2020 during the election cycle, when they were ballot counting and things were kind of neck and neck, I had some scripts that were monitoring web pages for critical races, and when things would change a certain amount, it would just speak an update to me, and I just had that on in the background, and every now and then there'd be an announcement saying, like, you know, so and so in Pennsylvania. Yeah, if you don't know it's there, though, it can be startling. All right, touch is a nice way to create a file if it doesn't exist, or update the date stamp on a file. So if I look for haha, I don't have a file with that name in there. If I say touch haha, now I have a file named haha, and it was created at 11:43. And so if you need a file to exist, you can copy dev null to it. But if it already exists, that will zero it out. So a nice way to create a file if it doesn't exist and do no harm if it does is just to use touch. And if you touch a file that exists, it just updates the timestamp. So now this shows as having been last touched at 11:44. All right, sudo is how we run system level commands. So if I try to say, edit the password file, it'll tell me, hey, that's read only, you can't edit that. If I put sudo in front of that command, it makes me the super user, the root user, and now I have permission to edit this file. And so if I say sudo bash, now I'm running a bash shell, but I'm logged in as root, effectively. And so I have full permission to do anything to any file I want. And so if you're running your own system, this is important, right? And the usual advice is don't just sudo bash, because if I accidentally, you know, rm-rf* in a directory I don't want to delete, I will delete everything in that directory. I tried to disable the bell sound, which maybe I did, and tried to use sudo. On the server, if you try to do that, it won't let you do it, because that would be trying to do it for everybody. But the terminal program you're running should have options for what to do with a bell. And usually you can switch to a visual bell, which will either flash or just ignore it completely. Yeah, so Linux is set up to sort of take care of itself, so it shouldn't let you do anything that it doesn't want you to be able to do. That's the whole reason for file permissions. Make, you know all about, right? Make files, and make goes through a make file and does what it says to do. So no surprise there. Zip and unzip. So if you've done Windows, you know about zip and unzip, right? So here's my PA4 directory. I can say zip tilde slash PA4.zip asterisk, and it takes everything in my directory and the subdirectory and adds that to this zip file. And now I've got a PA4.zip. And I can unzip it with just unzip PA4. I can do an unzip -L PA4.zip and see the contents of it. I can go into temp and unzip // PA4.zip. And now I've got, you know, a copy of my old directory structure sitting inside here. But the usual way to do this is with the tar command. So this is the tape archive command, and we've talked about this before, but we'll run through it one more time. So if I say tar cvf pa4.tar and then a starting directory, it will go through, it will go into all of the subdirectories, it will add each of those to my archive, and the V switch says, show me what you're doing as you do it. C says, create an archive. S says, don't put it on a magnetic tape, put it in a file, and here's the name of the file. And so now I have a directory called, a file called pa4.tar. I can tar tvf to see what's in that file. And it not only records the contents of the file, but it records the exact timestamp, the size, the ownership, the permission bits, all of that is preserved, right? So tar is really, you know, the way that we make archives in Linux, but it doesn't compress, unlike zip, which does. So we can use another utility like gzip on top of tar to create a compressed tar file. So if I go back into my temp directory and I do xvf for extract verbosely from the file pa4.tar, that creates a new copy of my files, including all my subdirectories. All right, so that's tar. Man is for listing manual pages on a command. So hopefully you've been using this. You've seen me use it a bunch. And remember, there's manual pages for the manual page command. So we can find out about it like that. And when you do the man command, right, you're running, your display is being run through the less command, and Control C won't actually get me out of this, right? But it always tells me hit a Q to quit. So if I just hit a Q, that gets me out. XXD is a command I've used to look at files that might not be otherwise readable. So if I do XXD curses, it shows me the contents of this file in hex. So over here is the position in the file, and then here are the ASCII codes for each character in the file. And over here is 16 characters that will be a dot if the character is not printable, or will be the actual character if the ASCII code is something printable. And so if there's human readable stuff in here, we'll see it, you know, nicely displayed over here. And if it's more binary, then we'll just see, you know, the ASCII codes. And so I can see my ELF in the very beginning, which says this is an executable file. And then the rest of this is, you know, the actual ones and zeros for the program. So XXD does that. There's also OD, which is just the octal dump program, which by default displays things in octal. And again, it's just showing me the octal value for each byte in the file, along with a location, or we can do -X to show it in hex and so on. And those can be useful if you're getting strange results. If you have a variable that doesn't seem to be acting right in bash, you can echo that variable and pipe it into OD or XXD and see exactly what you're getting. So if you're running Windows and you know, have a file from Windows, sometimes the lines don't end with just a new line. They end with a carriage return followed by a new line. And if you just copy that file over to Linux and you start trying to work with it, it might be doing weird things. Maybe it's an appointment file you built in Windows and each line ends with an ASCII character 13 before the new line. And that can be having weird effects. So you could take that file and you could look at it with something like XXD or OD and see exactly what the composition of that file is. Same thing if there's spaces, there's tabs or things like that. That'll be apparent from looking at the raw bytes of the file. All right, Git you know about, you've been using Git. Main things I need you to know for Git for the exam: Git add, Git commit, Git push, right? You definitely got to know those three because that's the basic drill for pushing things over to GitLab. There's other things though we do with Git. When we start a repository, we say git init. When we pull down a repository, we say git clone. And if we start playing with branches, we say git checkout to create a new branch. We also say git mv to rename and git rm to remove files that are under Git control. We can do git log to see a record of our changes, and we can do git status to see the current situation in our repository. So there's a lot of commands, but make sure you know git add, git commit, git push. And you should be doing those enough that they're entrenched in your memory. Find is a very useful command for looking for files. So if I say find dot dash name star dot c, this will search my entire directory tree for anything that ends with a dot c. And this is searching, you know, a few terabytes worth of storage, but it's pretty efficient, right? And find takes all kinds of options. So I can say, look for anything with the word test inside. And I've got lots of things with the word test. If I say dash I name, that will say ignore case. So it'll match uppercase, lowercase, or a mixed case test. And I can say dash and let's do an ls. So this will not only find files matching that name, but it will also do an ls-l on them. And really the most basic form, find dot dash name, and then a pattern. And you know, if your pattern is going to have wildcards, I have to put this inside double quotes. Otherwise, the shell will try to expand those wildcards. That's probably the most useful version of this. But there are a number of useful options beyond that. You can basically do logic on these. You can say find things with this name and with a size of at least 200 megabytes and with a timestamp showing that they were created within the past 3 days. And when you find those, execute this command. And so you can look at the manual page and see some of these options. So you can test for sizes, creation times, access times, whether the file is executable, whether the file's group ID is such and so on. So this will go through a potentially large file system and do a lot of very detailed searching. And it does it pretty quickly. It's a very efficient program. And, you know, of course, it understands regular expressions. So normally, if I just do this, I can wildcard with an asterisk or a question mark. And that's most of what you might end up doing with find, but you can get very nuanced and look for regular expressions and such. Git log -- one line is very helpful. Somebody posted that in chat. And that shows you a single line version of each log entry. And that can be good if you have a lot of activity on your repo and you're looking for it. You can take that and pipe it into grep and so on and so forth. All right, dialogue, you know all about. We've been messing with that for a while now. LN was the command for making links, and the basic structure is LN new and original, and this sort of violates this seeming protocol for bash commands of having like a source and a destination, or an old and a new. Here we say link this new file to some original file, and this becomes a symbolic link for that. I'm feeling like I have that backwards. Yeah, I got that backwards. Forget that. All right, so LN original file new, so it does kind of stick to the same structure. So this creates a link to an original file. And this is a hard link, so it'll actually duplicate the inode number. And if you say ln-s, then it's called a symbolic link. And this refers to that original file by name. So that's what I did in this test over here. I made a new file, which is a reference to this existing file, haha. So it's a symbolic link.
So what's the difference between a symbolic link and a hard link? Is it like if you delete the symbolic one, then the other one the original stays, but it doesn't if you do hard link?
So, so hard link is the easiest to understand because it's simply two files referring to the same stuff on disk. So if I say link old, new, old
It's like-
points to some file, new points to the exact same file. If I
So it's
delete
just putting
old,
the file in two directories at once.
sort of, yeah. If I
Sort of.
delete old, new still exists. If I delete new, old still exists.
Oh,
They're
okay, because it doesn't delete
both
the file,
files.
it deletes.
But if I say link symbolically old, new, I've got old pointing somewhere on the disk. I've got new basically referring to old. So if I delete old and I try to look at new, it's going to say can't find the file. So this is really making two things that are exactly the same. This is making a reference to something else. And mostly we do symbolic links these days. All right, and then curl. So curl is a nice command for scraping the web. So for example, if I say curl news.yahoo.com, it goes out to that location, contacts the web server, and makes a request, in this case for index.html, and then it displays, you know, whatever came back from that server. And so here I could, you know, take the output and send it into a file. I'll call it news. And you notice there's information being displayed, even though I'm redirecting my output to a file. This information was sent to standard error because I don't really want to see statistics on my transfer inside my file. I want my file to be the web page that came from Yahoo. So this information got sent to a different output stream, in this case, standard error. So now if I look at news, this is the HTML that came from, you know, news.yahoo.com. And a lot of this is, you know, JavaScript or, you know, formatting information and so on, but there may actually be text in here that could be useful. And if I put this into an HTML file, and I go to /home/Nick, and I open that up. So news.html. Well, my browser will render that file for me. And I can see, you know, what I would see if I was at Yahoo News, except I'm not at Yahoo News. I'm just looking at a file. And so all of this information is inside the file. And so if I were to search for election, right? So there's where it says election results. And so on and so forth. So this can be useful for various things. So for example, on the top of my window at home, I have a little bit of weather information that's displayed. It shows me air quality alerts. It shows me temperature and things like that. And that's done with this command called weather info. And when I run weather info, it shows me air quality and then temperature and wind speed and barometer and the time. And weather info is just a bash script. It's not even a long bash script. It's 31 lines long, but it uses this curl command. So here's where I get the weather. Here's where I get the air quality. So for example, I say curl, I use this URL to get the weather in Vancouver. This is over at Pearson by the Forge. I send the output of that into a temp file and I send standard error to dev null. So I don't see those statistics. And then I have a little function called extract, which does some stuff to get rid of all that hypertext tagging. Look for relative humidity, wind direction, wind miles per hour, wind gust, pressure, observation time. And each of those I break up into, you know, certain fields. And then I go to a site where I get the air quality, so EnviroFlash, and I break that up. And then I echo all of those fields. And I put a new line in the middle. And so when I run that, it gives me this information. And on the version of Linux I'm running, which is just a pretty generic desktop, it's Xubuntu. There's things I can put on my taskbar. One of them is called a generic monitor. And so I can specify a generic monitor. I can put whatever command I want in there. So here my command is this this weather info script. I can say how often to run it. I can put a label on it. I can change the font and so on. And when I put this in my taskbar, right, this information gets run every 5 minutes. The script runs and it displays the output. And so you can customize, you know, what your desktop looks like. And you don't need to be a wizard. You don't need to, you know, take a course in API programming for Android or things like that, right? It's just bash. It's doing nothing in here that we haven't already talked about, but it's putting things together in very particular ways. It's using some very strange looking regular expressions to get through all of the gibberish, the stuff that looks like gibberish on the web page, and get down to the good stuff that I'm actually interested in. But you know, you grab a web page's output, throw it in a file, hop into an editor and start looking for whatever it is you're interested in. And then figure out, you know, oh, when I get to the part that has the temperature, there's this set of words right before that. And so you use that to make a search pattern and you massage it with sed or awk and get the information you want. And it's just bash. It's very uninspired. It's very inelegant. But you know, 31 lines for a weather app, that's not bad. All right, so those are some commands you can look at. Like I say, you know, we haven't done anything with curl until 5 minutes ago. I'm not going to give you a bunch of questions on the exam about curl, right? but you will get questions on the exam about regular expressions and about, you know, the GCC command and what does it mean when you say GCC-C, and you'll get questions on sed and awk and grep and things like that. So my suggestion is, you know, go through this list and at least familiarize yourself with the things on it. But mostly keep it handy so that, you know, if down the road you're like, oh, I need to get the fourth line out of a file, how do I do that? You can come through this list. It's only a few pages. And it's like, oh yeah, head and tail, there was some way to do that. And you start playing with it and you'll figure out a way to do it. All right, we're at 12:05. I am out of here. So got office hours tomorrow morning at 7:30. If you have questions, otherwise, have a great weekend. I'll see you in 2:15 if you're there. Otherwise, I will see you next week. All right, thank you, everybody.
See ya.
Bye.
See you next time.